So in the last period we have already discussed the Bohr 3 postulate. As per the third postulate, when electron jump from higher energy level to the lower energy level, it emits the energy in the form of radiations, and energy of that radiation when it is to be jumps from higher energy level to the lower energy level is nothing but h into mu, where h is Planck constant and mu is the frequency of that radiations. Now we have to say that the equation of energy for nth orbit is given by the relation minus m e raised to 4 upon 8 epsilon square n square h square. We already derived this equation. Now we have to see when transition is to be occurring in between pth level to the nth level. At that time, how much radiation is to be comes out, the energy of that radiation is to be counted in the form of h into mu. So we have to say that the energy of p level is given by minus m e raised to 4 upon 8 epsilon square p square into h square. Instead of n, we have to put here p. Similarly, for energy of the charged particle in the nth level is minus m e raised to 4 upon 8 epsilon square n square h square. When it is jumping from nth level to the pth level, at that time we have to say that En minus Ep, that is difference between two energy levels, is given by relation En minus Ep is equal to h mu. Putting the value of En, putting the value of Ep, we have take common m e raised to 4 upon 8 epsilon square h square. We have to get 1 upon p square minus 1 upon n square. So transfer this h to this side. We have to get mu is equal to m e raised to 4 upon 8 epsilon square h cube into bracket 1 upon p square minus 1 upon n square. We know very well the relation between velocity of light, frequency and wavelength is given by relation c is equal to mu lambda. So mu is equal to c upon lambda. We have to put here c upon lambda is equal to m e raised to 4 divided by 8 epsilon square h cube into bracket 1 upon p square minus 1 upon n square. So transfer this c to this side, that is at the denominator. We have to get 1 upon lambda m e raised to 4 upon 8 epsilon square ch cube into 1 upon p square minus 1 upon n square. So instead of this we have to put one of the constant, that is r, we may call it as Rydberg constant. So 1 upon lambda is equal to r into bracket 1 upon p square minus 1 upon n square, where r is our Rydberg constant, m e raised to 4 upon 8 epsilon square ch cube. So mu bar, that is wave number, is defined as reciprocal of wavelength. So mu bar is equal to 1 upon lambda. So here we have to put mu bar is equal to r into 1 upon p square minus 1 upon n square. So what it says? It says that when electron is jumping from higher energy level to the lower energy level, at that time it emits the radiations which have the energy h mu. So here transition is from higher energy level to the lower energy level. According to that transition, there is a certain series is to be occurring, that is Lyman series, Balmer series, Paschen series, bracket series and P-Fund series. So in case of Lyman series, the final state is 1. Final state is 1. Radiation is from 2, 3, 4. And that radiation which is to be comes is of the type of ultraviolet. When we have to consider Balmer series, the final state is a 2 and initial state is 3, 4, 5. From 3, 4, 5 it is to be transferred from 3, 4, 5 to the 2, that is final state 2. That type of the radiation is of the visible type, that means we can visible it. So next one, when final state is a 3 and transition is from initial state 4, 5, 6 dash, that type of series is nothing but our Paschen series, and that radiations is near infrared. When final state is a 4 and initial state, that is the transition from which it is to be occur, is a 5, 6, 7, 8 dash, that is etc. say, then that type of radiation is infrared, and that series is nothing but the bracket series. And in case of P-Fund series, final state is a 5 and transition is from 6, 7, 8 etc. and it is a far infrared type radiation is there. So we have to say that when transition is to be occurring from higher energy level to the lower energy level, whatever the energy is to be get, that is in the form of product of Planck constant into the frequency of that wave. Using that concept, we have to here derive the relation for the wave number mu r is equal to r into 1 upon p square minus 1 upon n square. So p your final state and n is your initial state, r is your Rydberg constant and mu r is your. We just discuss what is the strength of Bohr model of an atom. We know very well the Rutherford model, Thomson model have their drawbacks, and then Bohr put forth its own model that gives us the idea about the structure of atoms. But when we have to say the strength of this Bohr model, or say importance of this Bohr model, we have to say that Bohr model is quite superior than that of the other type of models, because whatever the size of hydrogen atom is to be obtaining by using Bohr model, that value is near about same that of the, by another way, if you have to find the value of hydrogen size of hydrogen atom, that there is some correspondence in between these two value we have to obtain, we have to see. Therefore we have to say that the Bohr model gives near about clear value or accurate value of our size of hydrogen atom. By using the radius of hydrogen atom, we have to find that one. Then ionization value of the hydrogen atom also same as that of the another way. If you have to find the value of that ionization value, then we have to again see that there is a correspondence in between these both of them. That means it gives also correct or near about correct value of ionization. Then what is the strong evidence of emissions and absorption, which is in the form of the radiations which will obtain in say transition from higher energy level to the lower energy level, that is as per the Bohr's third model. What is the radiation is to be created, that is to be counted in the form of series of lines, that is called Lyman series, Balmer series, Brackett series. That gives us a strong evidence of presence of the emission of that lines from the when transition is to be occurring from higher energy level to the lower energy level. Again it gives the strong understanding or better understanding of periodic table which is given by scientist Mendeleev. That is also say give the strong evidence or strong understanding of periodic table by using the Bohr model. Then Bohr's take the idea of nucleus from the Rutherford model, but in Rutherford model only idea of nucleus is there, that is nucleus is one of the part, one of the core at the center of that atom at which whole say mass is supposed to be concentrated. But in this case, that is using Bohr model, it can be explained how the distribution of the electron is to be take place. It can be explained by using the Bohr model. We, along with this strength of Bohr model, we also observe some drawback of Bohr model. Bohr model are able to explain the size of hydrogen atom, but if atomic number is more than that of 1, at that time it is not able to explain the size of that particular atom. There is need some modifications. Then second one is that whatever the spectral line is emitted while transition is occurring from higher energy level to the lower energy level, the Bohr model says that it is a fine structure or fine rays, that is a single ray. But we have to observe that is not a single ray, but there can be split into one or more than 1, 2, 3 lines like this. So this cannot be explained by using the Bohr model. Third drawback is that when the material is subjected to the electric and magnetic field, the emission of spectral line is going to be increases, that cannot be explained by using the Bohr model. Then fourth drawback is that the relative intensity of that rays are not to be explained by using the Bohr model. And fifth drawback is that whatever the distribution of the electron in outermost orbit of that nucleus are not to be explained clearly with the help of the Bohr model. So we have to say that these are the drawback of the Bohr model. Now in this period we have to discuss Frank and Hertz experiment. Frank and Hertz, this is the name of scientist. With the help of this experiment, it gives support that discrete energy levels are to be present within that atom. That means it supports the presence of discrete energy level is there. So for the purpose of that, the experimental arrangement, if you have to look toward the figure, we have to observe that there is one of the tube. Within that tube, the low pressure gas is to be present. Generally, mercury gas is present. If you have to look here, this is one of the filament which is to be heated by this low tension battery. This is the grid or mesh through which the charged particle may enters and reach to the plate P. Plate P is a collector, say, or simply a positive plate P, which is connected to the ampere for measuring the current, and it is to be connected to 0.5 volt, that is a low voltage is also applied here, and variable voltage is applied in between filament and this grid. So initially what happened here, within this discharge tube, within this tube, there is the mercury atoms are to be present. And when we have to heated this filament up to the red hot, then according to the phenomena of thermoionic emissions, they start to emit the cathode rays. And as this grid is connected to the positive terminal of battery, the cathodes which have the negative charge, they all of us are attracted toward this grid. They are tried to reach toward the plate after entering through this grid. What happened in between this? Here is a mercury element, mercury atoms are to be present, and there may be the collision in between this negative charge particles with this mercury atom. And there is a two type of the collision is may be occur. One of them is a elastic collision, and second one is inelastic collision. So what happened when we have to change the voltage in between 0 to 5 volt, there is no current is to be observed in this ampere meter. But when we have to increase the voltage, at that time we have to see some current is to be observing on this ammeter. Here what happened? When the collision in between this negative charge particle and the mercury atoms are, say, type of the elastic collision. Elastic collision means the energy before the collision and after the collision are remain same. That type of collision is called as the elastic collision. When that type of elastic collision is occurring in between mercury atom and this negative charge particle, at that time we have to see that most of the charge particles are reaching to the plate P, and we have to observe the current which is going to be increases. At the point when the voltage applied is up to the 4.9 volt, at that situation, that collision in between that charge particle and the mercury is become inelastic collision. And because of that, what is the energy of that charge particle? They are all given to that mercury atom, and no charge particle or number of charge particles reach to the plate is going to be decreases. And so what the charge particle collected by plate is going to be decreased, and we have to get less, and the current is also going to decrease. That is, this part is to be arises. Again we have to increase gradually the voltage applied. Then at the beginning of this, that is after 4.9 volt, then if you have to increase again that voltage, we have to see that the current is going to be increases, because the collision between that negative charge particle and the mercury atom is the type of the elastic collision, and because of that the most of the charge particle is reaching at the point, say plate P, and the current is going to be increases. Again, when 9.8 volt is to be reached, at that time, again due to the inelastic collision, the energy of that charge particle is going to be lost, and number of charge particle collected at plate is going to be decreased, and therefore current is also going to be decreased, and again this peak is to be arises. So again at the 4.7 volt we have seen that the next peak will be arises. So in the difference of 4.9 volt, the different peak which to be observed, it shows that the discrete energy levels are to be existing there. So we have to see this Frank and Hertz experiment which support that distinct or discrete energy level is to be present there.